Hi guys, Dr. J here, and in this video I'm going to go through a little demonstration of sensitivity analysis for you. Now sensitivity is a big topic and a lot of different things that you can do, and there are several mentioned in the book. I'm just going to go through a very simple exercise here where we'll look at how in our very simple reservoir storage model changes in the porosity and the thickness affect the reservoir storage volume that we estimate. And we'll look at which parameter is more important to constrain given that sensitivity analysis. So here we go. Here's our reservoir storage model in Google Colab. So what I've done here is, instead of generating a whole bunch of random samples that represent the distribution of porosity, I've just taken the lower and upper 95% confidence bounds. And you can see that here. So as you recall, our prior model for porosity is 27% plus or minus 3%. So I've taken 27% minus 2 times the standard deviation. That's for a Gaussian. And that is, of course, 0.06, 2 times 0.03. And then I've got the mean here. And then I've got the high end of the Gaussian. So again, 2 standard deviations for Gaussian is 95% confidence. So I'm taking the upper and lower 95. I'm taking the confidence interval that is the upper and lower values that give me a 95% confidence of that distribution. For thickness, because this is a uniform distribution, I'm just taking the upper and lower bounds. So thickness is assumed to be between 10 and 14 meters, an average of 12. And so I'm going to take the upper and lower bounds for that distribution. Now, of course, when we're comparing these two parameters, we're doing sensitivity analysis, seeing what is more important, and you want to make sure that the bounds that you use are appropriate for the parameters themselves. So in this case, I think we're actually doing okay, even though maybe you would say, well, maybe we want to take the 95% confidence bounds on thickness rather than just taking the absolute bounds. But in this case, I think it's not a problem because of the fact that we are assuming thickness is uniformly distributed. And then, of course, here's our basic reservoir model where we just have porosity times thickness times area. Okay, so with this, I'm going to go ahead and run each one of these cells just to make sure we're got all these variables in our memory. And again, you don't see anything happening, nothing's printing out. That's because I'm assigning to variables, and so you won't necessarily see anything printed unless I put in a print statement. And again, our function should be defined now. We can call that function now from within a cell. So what I'm just going to do is I'm going to very simplest thing I'm going to do is I'm going to compute what the minimum and maximum reservoir storage is, varying only one parameter at a time. All right, so let's start out with porosity. Okay, so let's see here. Low storage phi is going to be equal to reservoir storage for phi low. So I'm going to use the low porosity value. I'm going to use the mean thickness, right? So this is a sensitivity analysis, so we have to fix one variable while we vary the other variable. And that's how we're going to see which variable is more important. So I'm just going to use the mean value for the one that I'm not varying. I'll use the low porosity in this case. This is the low storage model. I'll just copy and paste here. I'll do the same thing again, but for the high porosity. And yep, I'll take that one there, and then I'll call this high. So I'm naming my variable something so I know what it is. So this is the low porosity value. This is the high porosity value. I'll go ahead and run this cell. And again, you don't see anything because I haven't said to print anything. So let's go ahead and print these values. So let's print low storage, and let's print high storage to 1 decimal place. And just run this again just so we can get rid of those annoying decimal places. There we go. Okay, so here we are. So we've got a storage, and this is again in cubic meters. And again, we've talked about this before where you might want to convert this into better units depending on what you're doing. Here's cubic meters, low storage. If you assume the low porosity value, you get one, and the high porosity value, you get the other. We can do the same thing for thickness. And again, I'll just copy paste here. And now I'm going to say, instead of phi, this is going to be thickness. And I'll go here. And now I'm going to change this to thickness high, thickness low. And now porosity I want to have fixed because I'm varying the thickness. Thickness changes. Compare these and see which one has a bigger impact. And then we'll print the high thickness minus the low thickness, and we'll compare. So the variation in storage, reservoir storage, given the uncertainty in mean porosity is, in this case, 57,600 cubic meters. The uncertainty in storage due to uncertainty in reservoir thickness is only 43,200 cubic meters. So from this exercise, you can see that the uncertainty in porosity actually has a bigger impact on the uncertainty in reservoir storage volume than the thickness does, at least if you're looking at each variable by itself. So this is one very simple way to do sensitivity analysis. As I said, there are other ways, and we'll look at those in the book, but I wanted to give you just a basic understanding of what this means when we're doing sensitivity.